So today here we're going to be talking about Ohm's Law Lab. So Ohm's Law Lab actually relates here current, voltage, and resistance. So what we have set up here is actually a simple circuit here. So we have our sensor here which actually measures both voltage and current. So this here actually is going to be measuring our current here, and current is actually going to be measured here in series. This is actually done here because we need to actually, the electrons here need to be kept moving without, preventing it from, not moving. So it's going to be moving along the circuit here. It's going to pass through our resistor because we need to have resistance in our circuit to prevent, the electrons here to not go freely, short circuit, blow anything up, because let's face it, we already have fancy equipment enough. We don't want to ruin it. So it's going to, go through the battery here. We're going to measure here on our equipment, and then we're going to be actually measuring here the voltage.
So the voltage then, remember, voltage is energy per charge, and coming out of the end of our sensor, we'll measure our voltage, and what we'll do is we'll place that on either side of whatever it is we want to measure the voltage for. If we wanted to do the resistor, we'll hook them on both sides of the resistor. If we wanted to find either side of the battery, we would hook it on the sides of the battery. Remembering that each battery is roughly 1.5 volts, so you can tell this is a newer battery because it's a higher voltage, 1.6, and then as the batteries get drained, they will go down to like 1.2, 1.1. So I'm gonna go ahead and click this on here, and then what we'll do is we'll start by connecting our circuit and starting to measure our values off of the sensor. Okay, so what we're gonna do is hook up one battery to the sensor, to the circuit, and notice that we get a reading for all three of those. So I'm going to stop it, and then I'm going to write down what I got. I have one battery. The current is 4.12 times 10 to the negative 3 amps. The voltage is 1.6 volts, and then the power is 6.57 times 10 to the negative 3 watts. And what we'll do is we'll keep doing that, where we'll add another battery and get a reading. So this next one will be 2 batteries, and then 3 batteries, and then 4 batteries, and then 5 batteries.
Okay.
Okay, so here we go with 2 batteries. And 2.44 times 10 to the negative 2 watts. And there we go. So we have 1.08 times 10 to the negative 2, 4.72, and 5.10 times 10 to the negative 2. Next up, we'll put in a 4th battery. Oops. There we go. 1.44 times 10 to the negative 2, 6.28 times, not times anything, and 9.04 times 10 to the negative 2. And the last one, we'll add a 5th battery. And there we go. 1.80 times 10 to the negative 2, and 7.78, and 1.4 times 10 to the negative 1 watts. Now the last thing that we're going to do here is that you have this table and you want to calculate what power is. Remember that power is your current times your voltage, so you're literally going to multiply these two together to get this column, and then we want to compare the two columns. After that, you're going to go into Google Sheets or into Excel, and you're going to create a graph of the voltage and the current, because we want to see off of that graph what the graph looks like, whether it's direct or inverse, and whether it's linear or exponential. And then from there, you're going to answer your questions on the sheet and or answer the questions in Buzz.